Hi there once again. On this video you're going to learn about correlation and how to calculate the correlation coefficient. Okay, some of you might have already learned what correlation is about from your GCSE maths. Okay, so let's look at a quick example how you use this thing called correlation. So let's create a scatter graph between two variables. So a scatter graph like this, and let's say on the x-axis you have weight and on the y-axis you have height. So you would expect weight and height to correlate like this. Okay, you would expect most people who are heavier to be taller as well. All right, not strictly the case every time, but that's what you'd expect. So your line of best fit, let me use a red pen to show you. The line of best fit may look something like that. Okay, so the line of best fit is the line that is drawn closest to as many points as possible. Maybe I could have done better with the line of best fit. It doesn't necessarily need to go through all the points, as many points as possible. It needs to be as close as possible to as many points as possible. And a line of best fit drawn like this would have a positive correlation. Okay, right. Let's look at an example where you'd get a negative correlation. All right. Let's just say you had to do a test tomorrow, and you went to bed, and you had a certain number of hours of sleep. Okay, so if you had fewer hours of sleep, so that's hours of sleep on the x-axis, hours of sleep, and on the y-axis you have incorrect answers or wrong answers for the test that you're doing tomorrow. Okay, so on the x-axis the number of hours of sleep you had, and on the y-axis the number of wrong answers that you had. All right, so you would expect the correlation to look something like this. Okay, the scatter graph would look something like this, and if I drew a line of best fit through this, it might look something like this. All right, so you would expect, if you slept a little, you would expect to get a lot of questions wrong, whereas if you had lots of hours of sleep, you would expect to get lots of very little answers wrong. Okay, so strictly speaking, it may not be the case, but it's just a very easy example of a negative correlation situation. All right, okay, so if one thing increases and the other thing increases, it's a positive correlation. If one thing increases and the other thing decreases, it's a negative correlation. Okay, good. Let's look at a situation where there is absolutely no correlation between two variables or two quantities. Okay, let's just say you're trying to look at the correlation between those who are those who have obtained marks for maths and those who have obtained marks for music. All right, now if there is any sort of relationship, if those who are good at maths are also good at music, you would expect the graph to look like this, the line of best fit to look like this. If those who are good at maths and aren't good at music, then you would expect the correlation, the line of best fit, to look something like this. But if there isn't any relationship, okay, if you're good at maths, you may be good at music, you may not be good at music, or if you're good at music, you may be good at maths and you may not be good at maths. So if that was the case, then you'd get a scatter graph that looks like this. Okay, you won't be able to draw a line of best fit in any sort of direction. Okay, you can't say the line of best fit is this way or this way. You just don't know. All right, so this is a situation where there is no correlation. Okay, so far we've looked at three types of correlation. we've looked at positive correlation, we've looked at negative correlation, this one here, and we've also looked at a situation when there is no correlation at all. All right, so now how do we test the strength of the correlation between two variables? Okay, so let's look at two situations like this. Okay, one scatter graph looks like this and the other scatter graph looks like this. All right, so we can see in both scatter graphs it's a positive correlation, isn't it? If I drew a line of best fit, it'll look like that. If I drew a line of best fit like this, it looks like that. Okay, but you can see in example A, the dots are more closer to the line, whereas in example B, the dots are slightly more scattered about this line of best fit. Okay, so we can call these both positive correlations, but this has a stronger positive correlation. Okay, so the strength of the correlation needs to be expressed using some value. All right, so that value is basically called the PMCC, which stands for the product moment correlation coefficient. Okay, so that's called the product moment correlation coefficient. Okay, now the PMCC for this will be something like 0.9. Okay, for this it probably something like 0.6. Okay, so as you can see, there's more scatter about the line of best fit. The PMCC goes down. Okay, there is a negative scale also to this PMCC. Now that is used to describe any negative correlations. All right, so if your scatter graph looked something like this, now your line of best fit would look something like this. Okay, and the PMCC in this instance would be negative 0.8. okay, so if there is a perfect negative correlation, so if this was your scatter graph and all your points, all the dots, they were on this line of best fit, that would be a perfect negative correlation. That would have a PMCC of -1. Okay, so the PMCC values have a range from -1 to +1, and depending on the strength of the correlation, it'll vary between these two values. Okay, if the PMCC is 0, there is no correlation at all. Okay, no correlation at 0. Whereas at +1 it's positive, -1 is a negative correlation. Okay, now I'll give you examples like at a random point on this range. Let's say the PMCC was 0.3, positive 0.3. It's a very weak positive correlation, so it would look something like this. The line of best fit would be something like this. Okay, it's a barely, it's a positive correlation, but only just. All right, because there's lots of scatter about the line of best fit. All right, now we'll look at how we could calculate this PMCC value. Okay, now to do that, we need to be given precise x and y coordinate values, okay, of the scatter graph. Okay, so that's my x values and that's my y values. Okay, I'll make my x number of hours of sleep, and y is the marks obtained, okay, by a student in an exam. Okay, so after an exam, you ask the student how many hours of sleep they got, all right, the night before, and the marks they achieved in that exam. Okay, so let's put these values. Okay, let's say we obtain these values. Okay, now this is just a crude example. This may not be the case in actual practice. Okay, but for this section I'm just using this example. All right, so as the number of as the sleep increase, you can see that the amount of marks they obtained also increases. Okay, now let's see what's the strength of this correlation. Okay, so if I were to do a scatter diagram for this, it probably looks like this. So for the exam, you be expected to construct this scatter graph. So you'd be expected to plot your x coordinates and your y coordinates. Okay, now let's try and work out the PMCC for this. Okay, you need to know 3 intermediate variables for this. All right, and the derivation of these 3 variables or these coefficients, these intermediate coefficients, you don't need to know the derivations. Okay, you don't need to know the explanations behind this for your exam. Okay, if you are really keen on knowing this, you can do a Google search or you can go to Wikipedia. You can read up on this, but for your A-level exams, all you need to know is how you calculate these intermediate coefficients. Okay, the 3 coefficients are sxx and syy and sxy. Okay, to work out sxx, we'll start off with sxx. This is what you need to do. Okay, now this looks a bit complicated, but it's quite straightforward. Okay, this sign, this E sign, stands for sum of. Okay, sum of all the x squared terms. Okay, so you square every x value and you add them all together. All right, okay, so I'll do it term by term. First one, so sum of x squared, so it's just 1 to 8, so I square everything and add them all together. Okay, and I get this answer. Next, what I do is I add up all my x terms and then square it. Okay, so I add up from 1 to 8, which is 36, and then I square it, which is 1296. So I add all my x terms, which I did before. I add up from 1 to 8, and then I square that result, which is 36, and get 1296. Okay, then I need to divide this by the number of terms I have. Okay, and n stands for the number of terms. Okay, so that's 1296 divided by, I have 8 terms. Okay, that's equal to 162. I'm so sorry, I think I made a mistake here. This answer here is not what I wrote before. It's actually 204. I don't know how I got that wrong. I beg your pardon. That's 204. I'm sure some of you might have been scratching your heads there. So that answer there is 204. I square each term of x and then add them all up. All right, that's 204. Okay, now let's use those answers. Okay, so that's sum of x squared. That's 204. Sum of all the x's, then square it. That's 1296, and then you divide it by the number of terms you have. That's 8, and then you get 162. So that's 1204 minus 162. You get 42. Okay. Now you do exactly the same thing with for the syy coefficients. Okay. So what you would do is, let me have a look at the sxx. Yeah, so you do sum of y squared minus sum of y, and you square that whole thing divided by n. Okay, so why don't you have a go at this? Okay, now this is what I get from my syy. All right, I square all the y terms and I add them all up, and then I add up all the y terms. Okay, that is 467, and then I square them. All right, and then I divide it by 8. All right, so these are the values here, and the final answer is 493.875. Okay, so I've done my sxx and syy. All right, now I've got to solve for my sxy. Okay, now the sxy coefficient you calculate by doing this, following this formula. All right, you sum all the x and the y terms multiplied together. Well, each individual x term multiplied with its relevant y term, and you add them all together. Okay, that's what this means. Okay, so the first xy term would be 1 multiplied by 45. So the first xy would be 45. The second xy would be 104. Okay, so let me write that out clearly for you. Okay, now the answer to that is 2244. Okay, the sum of all of this. All right, next you have to work out your sum of x times sum of y. All right, now that's basically the sum of all the x terms times the sum of all the y terms. Okay, now that answers this. Then you'll have to divide that result by the number of points you had. So that's 8. So 16812 divided by 8, you get, okay, you get that. All right, so we have to do one more thing. I have got to subtract one from the other. Okay, so I've got to subtract this from my sum of x y's. All right, so that's 2244 minus 2101.5. I get 142.5. Okay, so that is our sxy term. We have our syy term, and we have our sxx term, which is this. Alright, so those are the three intermediate coefficients that you need, okay, to figure out the PMCC. Alright, now, okay, there's one more thing you need to do. The PMCC, or you give it a notation of R, stands for, well, that's a PMCC. How you calculate that using the SXX, the SXY, and the SYY, you'll have to do this. Okay, you've got to divide the SXY term by the square root result of the SYY times the SXX. Okay, that's what you've got to do. All right, if I do that, I get this result, 0.989. okay, so that's a very, very strong positive correlation. Okay, remember the scaling, remember the range of values that R could be. R could be anything from -1 to +1. If it's +1, it's an absolutely perfect correlation, positive correlation. If it's -1, it's absolutely perfect negative correlation. If it's on 0, there is no correlation at all. Okay, the value that we've got here for this example, okay, for this set of values for x and y, all right, the PMCC that we've got is 0.989, which is a very good positive correlation. Very, very good positive correlation. Okay, now in exams, a lot of the times they say interpret this value when you consider the situation, well, when you consider all of these values. Okay, interpret that value of 0.989. What does that mean for this set of values? Okay, what does that mean? All right, now because there's a strong positive correlation, that means when one increases, the other increases. Okay, so for the Edexcel exams, when they say interpret that value, that PMCC value, you don't say, oh, it's a strong positive correlation. You've got to say, as x increases, y increases in context of the problem. Okay, now the variables that were defined as x and y, they were number of hours of sleep. Okay, so as the number of hours of sleep increases, the marks you obtain for the test next day increases. Okay, so that will be your answer. Okay, when they say, oh, interpret this PMCC value in context. Okay, you've got to say number of hours of sleep increases. As the number of hours of sleep increases, the marks you obtain for the test next day increases as well. Okay, I've noticed a lot of students, they just say, oh, it's a strong positive correlation. You won't get any marks because you've not interpreted that value. Okay, as a statistician, you know what this value means. Okay, but you've got to interpret this value of 0.989 in layman's term, okay, in context, okay, of this problem, so that a person who does not know statistics knows what you're talking about, and that's what they're looking for. Okay.